some special cases of binomials that show up in algebra very frequently, so frequently that it's useful to have a formula to attack these type problems. And so that's what we call special binomials. And I just want to remind students again that factoring turns addition and subtraction expressions into multiplication expressions, and so for that reason it's very, very useful. So here are three special binomials. You may have something that looks like a squared minus b squared. If you do, that factors as a minus b times a plus b. So I have here for part A, I have an example like that. I have something that I think is a perfect square minus something that I think is a perfect square, and they are. In fact, because 49 is the same as 7 squared, x squared is x squared, so I have 7x squared. If you multiply that out, you get 49x squared minus 12 squared. So 144 is 12 squared. So if you need to, you could jot down a note and say, well, that's my A and that's my B. So when I plug it into this formula here, I end up with A minus B, which would be 7x minus 12, times A plus B, which is 7x plus 12. And there it is. So this is called the difference of squares. Difference of squares is very, 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 very useful. We see it all the time. Okay, the next special binomial we can encounter is an a cubed minus b cubed. And if you have an a cubed minus b cubed situation, it factors as a minus b times a squared plus ab plus b squared, and that a squared plus ab plus b squared does not factor. So as an example of that, let's look at part C here, where you have x cubed minus 1000 y cubed. And so I notice here that this is x quantity cubed, and 1000 is actually 10 cubed, and so I have 10y cubed. If you need to make a note, you can say, well, my a is x and my b is 10y. So now when I plug that into my identity here, my formula, I end up with a minus b, which I said is going to be x minus 10y, times a squared, which is x squared, plus ab, which is 10xy, plus b squared, which would be 100y squared. And now it is factored. Okay, the third binomial you'll encounter is an a cubed plus b cubed. And so we can see here in part B, we have that situation. And I can rewrite 27 as 3 cubed. And a to the ninth, this may be a little tricky, is a cubed quantity cubed. Because remember, we have the property that says a to the n power to the m power is just, you multiply the exponents, a to the mn power. So a cubed cubed is a to the ninth. Now on the other side of that, we have 8, which is 2 cubed, and b to the 12th, using the same logic here, is going to be b to the 4th quantity cubed. Alright, now again, here's my a, here's my b, and I'm plugging it into this expression, which says a plus b, so that's going to be 3a cubed plus 2b to the 4th times a squared. So when I square 3a cubed, I get 9a to the 6th. Remember, you have to multiply your exponents. Minus a times b, which is going to be 6a cubed b to the 4th plus b squared, which is going to be 4b to the 8th power. Again, because 4 times 2 is 8. And there it is, it's factored. These aren't too hard. You just might have to practice plugging them into the appropriate formulas and actually committing these formulas to memory. I hope this makes sense. Please let me know if you have any questions, and thanks for watching.